You open the fridge, pull out something wrapped in plastic, and put it in a machine that heats it in 90 seconds using invisible waves. 90 seconds later, you're eating. You don't think about it as a miracle, because it isn't one anymore. It's just Tuesday. But strip away the microwave, the fridge, the plastic, the stove, all the way back, and you're left with the one step underneath all of it that actually changed what a human being is. Heat applied to food on purpose, not a convenience. A hinge point, one your entire species pivoted on without ever voting on it. And once you understand what that hinge point actually did to your ancestors' bodies, a plate of leftovers looks a lot less boring. Start with the obvious assumption because it's wrong in an interesting way. You probably think cooking started because raw meat tastes bad, or because fire kills germs, and both of those things are true enough. But neither one explains why cooking mattered evolutionarily. The real story isn't about taste or safety. It's about energy, and specifically about where a very expensive organ, your brain, got the fuel to grow as large as it eventually did. The biological anthropologist Richard Wrangham built an entire career around a single blunt idea called the cooking hypothesis. Controlled fire didn't just change what early humans ate, it restructured their biology from the inside out. His argument is that cooked food is fundamentally easier to extract energy from than raw food, and that easier extraction freed up a metabolic budget that got spent somewhere else. On a brain that gram for gram burns through roughly 20 times the energy of muscle tissue. A body can't just grow an organ that expensive for free. Something else has to give. Wrangham's case is that cooking is what gave. To see why cooking actually saves the bodywork, you have to think about digestion as a kind of labor, because that's exactly what it is. Chewing burns calories. Digesting raw, tough, fibrous food burns even more, and it takes a long time doing it. The biological anthropologist Catherine Zink, working with Daniel Lieberman, measured this directly by having people chew raw versus cooked food and tracking the muscular effort involved. Their results, published in the journal Nature, were stark. Cooking meat cut the number of chews needed by roughly a factor of 2, and combining cooking with basic slicing cut it even further. Scale that up across every meal, every day, for an entire life, and you're looking at a staggering amount of freed up time and jaw effort. Hours that a raw food ancestor would have spent literally grinding their meal into a swallowable pulp, one chew at a time. But saved chewing time is only half the story, because cooking doesn't just make food easier to eat. It makes food easier to digest once it's already swallowed. The biologist Rachel Carmody, working alongside Wrangham, ran a set of experiments feeding mice matched diets of raw versus cooked meat and raw versus cooked starch, then tracking body weight and energy absorption. The cooked food mice consistently gained more weight and extracted more usable energy from identical amounts of food. Heat denatures proteins, unwinding their tightly folded structure into something the gut can break down far more efficiently. Heat also gelatinizes starch, cracking open the tough granules that a raw digestive system can barely touch. Cooking, in other words, functions like a head start on digestion, done outside the body instead of inside it. You're not eating more food, you're extracting dramatically more out of the same food. You don't have to reconstruct Ice Age digestion in a lab to see this play out either, because it's already been tested on modern humans, if inadvertently. Researchers studying committed raw foodists, people who deliberately eat nothing cooked at all, with every advantage of modern food science behind them. Blenders, dehydrators, an enormous year-round variety of imported produce keep running into the same wall. A survey published in Annals of Nutrition and Metabolism by the nutrition researcher Corinna Kobnick and colleagues found that a large share of long-term raw foodists were underweight, and that women eating an especially high proportion of raw food experienced amenorrhea, the loss of a regular menstrual cycle, a strong biological signal that the body has judged its incoming energy supply too unreliable to safely support reproduction. These are people choosing raw food voluntarily in wealthy modern conditions, with none of the scarcity, cold, or physical labor an actual Ice Age forager faced every single day. If a raw diet can strain a well-fed modern body that badly under ideal conditions, it gets a lot easier to believe that raw food alone, eaten under real Pleistocene conditions, simply couldn't have kept pace with what a growing, energy-hungry human brain needed. Now put a number on when this actually started, because the archaeology is stranger and older than most people expect. At Wonderwork Cave in South Africa, the archaeologist Francesco Berna and his colleagues examined ash and burned bone fragments buried deep inside the cave, far from any entrance where wildfire could plausibly have reached. Their microscopic analysis, published in the Proceedings of the National Academy of Sciences, found the telltale signatures of wood ash and burned plant material consistent with a controlled fire maintained inside the cave roughly 1 million years ago. That's a staggering amount of time before modern humans existed at all. Whatever hominin was tending that fire, it wasn't Homo sapiens. It was something more like Homo erectus, a full evolutionary chapter earlier than us, already sitting beside a fire it had learned to keep alive. Further evidence comes from Sesame Cave in Israel, where excavators found a large, repeatedly used hearth surrounded by burned bone fragments and flint tools scarred by exposure to heat, dated to somewhere between 300,000 and 400,000 years ago. This wasn't one lucky campfire. It was the same spot, used the same way, again and again for an enormous stretch of time, which is exactly the pattern you'd expect if cooking had already become routine rather than exceptional. By this point, fire wasn't a discovery anymore. It was infrastructure, the same way a stove is infrastructure to you now, except this one had to be fed by hand and never allowed to go out. And the fossil record shows the biological side of this shift happening in step with it. Compare a Homo erectus skull to one from an earlier hominin, and the differences line up almost exactly with what you'd predict if cooked food had become a regular part of the diet. Teeth shrink, jaw muscles shrink, along with the bony ridges on the skull that used to anchor them. The gut shortens too, because a smaller, less energy-hungry digestive system is all you need once food arrives partially broken down by fire, instead of requiring your body to do all that work internally. Every one of those changes trades away tissue that used to be expensive to maintain, and biology doesn't give up expensive tissue for nothing. It gives it up because something else, in this case a rapidly expanding brain, needed the energy more. There's a social layer to this too. Easy to miss if you're only thinking about calories. A fire has to be tended, which means it becomes a fixed point that people return to. Raw foraging is scattered. You eat where you find something, whenever you find it, mostly alone. Cooking around a shared fire is different. It pulls people toward one spot at a predictable time, and a predictable shared mealtime is a strange thing to take for granted because it's essentially the first scheduled social gathering in human history. Sitting, waiting, watching food change over heat, talking while it cooks, keeping half an eye on the dark beyond the firelight. That's not just nutrition, that's the earliest visible shape of something like a family dinner, a stretch of unstructured face-to-face time built directly into the act of eating, running on infrastructure nobody today thinks twice about maintaining. So the next time you're standing in front of a microwave, waiting out those 90 seconds for something to go from cold to edible, it's worth remembering what you're actually the end result of. Not laziness, not a modern shortcut layered on top of real eating. You're standing at the far end of a chain that stretches back roughly 1 million years, through Homo erectus tending a fire in a South African cave, through a hearth in Kesem, reused for tens of thousands of years running, through skulls and jaws and guts that quietly reshaped themselves around the fact that heat had become part of eating. Cooking didn't just change your dinner, it built the brain currently reading these words, and it did it slowly, meal by meal, fire by fire, for far longer than anything you'd recognize as civilization has existed.